5. Common mistakes in DIY lithium battery. Wiring transitioning to lithium power is one of the most rewarding upgrades you can make for a van, boat, or off-grid cabin. A good lithium setup gives you more usable power, faster charging, less weight, and a much better off-grid experience overall. But here's the part many DIY builders underestimate. Lithium systems are not forgiving. A single loose connection, the wrong cable size, or one missing fuse can do more than cause a minor problem. It can shut your system down, damage expensive equipment, melt insulation, or in the worst case, create a serious fire risk. That is why this topic matters so much. If you are building your own system, upgrading an RV, or planning a more capable off-grid setup, understanding the most common lithium battery wiring mistakes can save you money, stress, and a lot of dangerous trial and error. In this video, I am walking you through 5 of the most common mistakes people make in DIY lithium battery wiring, why those mistakes matter, and what to do instead if you want a system that is safe, efficient, and reliable for the long haul. Let's start with why lithium wiring needs extra care in the first place. Lithium batteries behave very differently from traditional lead-acid batteries. They can deliver and accept high current very quickly, which is one of the reasons people love them. But that same strength is also what makes wiring quality so important. A lithium battery bank can keep supplying a large amount of current until it is nearly empty. That means your cables, lugs, fuses, connectors, and protection devices all need to be able to handle sustained demand without becoming the weak point in the system. When wiring is poorly planned, 2 big problems usually show up first. The first is heat buildup. Resistance in wires or connections turns electrical energy into heat. In a battery compartment or enclosed cabinet, that heat can damage insulation, degrade components, and trigger shutdowns. The second is voltage drop. When the wrong wire size is used or cable runs are too long, appliances may not get the voltage they need. Your inverter may complain, performance drops, and the whole system becomes less dependable. So when we talk about proper lithium battery wiring, we are not talking about perfection for perfection's sake. We are talking about safety, efficiency, and making sure the system actually works when you need it. Now let's get into the mistakes. The first mistake is using the wrong wire gauge. This is one of the most common DIY lithium battery wiring mistakes, and it is also one of the easiest to underestimate. A lot of people look at a cable and think, that looks thick enough. But in off-grid electrical systems, looks mean nothing. The numbers are what matter. Lithium systems can push high current through cables for extended periods. If the cable is too small, resistance increases. That creates heat, wastes energy, and can lead to performance issues under load. You may notice cables getting warm, you may see voltage drop, you may even have an inverter throwing errors even though the battery bank is fully charged. Here is a practical example. A 2,000-watt inverter on a 12-volt system can draw close to 200 amps. That is a serious amount of current. Depending on the cable run, you may need heavy cable like 2-aught or even 4-aught to do that safely. The key takeaway is simple. Always size your wire based on maximum current draw, total cable length, and acceptable voltage drop. Not average use, not guesswork, not what a cable looks like in your hand. And if you are ever unsure, sizing up is usually the safer decision. The second mistake is loose or poorly crimped connections. Even when the cable size is correct, a bad connection can still create a major problem. In fact, some of the most dangerous failures happen at the connection point, not in the wire itself. A lot of DIY builders use pliers, a hammer, or some improvised method to crimp battery lugs. The result often looks fine from the outside, but inside the connection there may be tiny air gaps. Those air gaps increase resistance, and resistance means heat. In a stationary system, that is already a problem. In a moving setup like an RV, van, or boat, it gets worse. Constant vibration can loosen a mediocre connection over time, increasing the chance of arcing or failure. A proper crimp should be tight, secure, and gas-tight, meaning there are no spaces inside the lug where heat and resistance can build up. This is one area where the right tool really matters. A hydraulic crimper or a proper heavy-duty crimping tool is not a luxury. It is part of building a system that lasts. The third mistake is reversing polarity. This sounds like the kind of mistake only beginners make, but that is not true. Even experienced builders can make a polarity mistake when they are tired, rushed, distracted, or working in a tight compartment with poor lighting, and when it happens, the results can be immediate. Connecting positive to negative can destroy sensitive components such as your inverter, your charge controller, or your battery management system. Modern electronics usually do not forgive polarity errors. The good news is that this mistake is very preventable. Label every cable clearly. Use red and black heat shrink. Keep your layout organized. And before making the final connection, verify polarity with a multimeter. That simple 30-second check can save you from a very expensive repair. The fourth mistake is skipping fuses or circuit protection. This is one of the most dangerous mistakes in the entire system. Fuses and breakers are not optional accessories. They are your first line of defense. If a short circuit happens, the fuse is designed to interrupt the current before the wire overheats or turns into a heating element. Without proper protection, a lithium battery can release extremely high current in seconds. That is what makes this so serious. You are not dealing with a weak power source. You are dealing with a very capable battery bank that can dump energy fast. Every positive cable leaving the battery should have a properly sized fuse or breaker installed as close to the battery as possible. That placement matters. The point is to protect the wire from the very beginning of the run. Skipping this step puts the entire system at risk. And it is one of those mistakes people often regret only after something goes badly wrong. The fifth mistake is incorrect battery management system wiring or configuration. The battery management system, or BMS, is the protective brain of your lithium battery. It monitors voltage, temperature, and charge and discharge limits to keep the cells within safe operating range. If the BMS is wired incorrectly, bypassed, or misconfigured, those protections can fail. In a DIY battery build, even one misplaced balance lead can cause inaccurate readings. That can lead to overcharging, over-discharging, or uneven cell behavior that damages the pack over time. This is one place where guessing has no place at all. Always follow the exact manufacturer diagram. Double-check every balance lead. Confirm every connection before powering the system, and never bypass the BMS just because it seems inconvenient. If it is stopping something, there is usually a reason. Now, if all of this sounds a little overwhelming, here is the good news. You do not need to be reckless to build your own system. You just need to be methodical. If you want to wire lithium batteries safely, start with a clear plan. Sketch the system out before you cut a single wire. Map the battery, bus bars, fuses, inverter, charge controller, and loads. During installation, use high-quality flexible copper cable meant for automotive or marine environments. Work one connection at a time, crimp properly, seal with heat, shrink. Label both ends of every cable. Before you power anything up, check polarity with a multimeter. Confirm that your fuses and breakers are in the right places. Inspect every connection for tightness. Then, test the system with a small load before putting it under serious demand. And before you switch the system on for real, run through a simple checklist. Correct wire gauge, properly crimped connections, heat shrink in place, polarity verified, fuses installed near the battery, BMS wired exactly as specified, terminals tightened correctly, and system tested on a low load first. That kind of discipline is what separates a dependable system from one that causes endless problems. It is also worth knowing when to stop and get help. DIY is a big part of the off-grid lifestyle, but knowing your limits is just as important. If you are still unsure about wire size, fuse ratings, system layout, or higher voltage configurations, bring in a qualified professional before you move forward. Building your own power system is a major step toward energy independence, but it comes with responsibility. Avoiding common DIY lithium battery wiring mistakes like undersized cables, poor crimps, reversed polarity, missing fuses, and incorrect BMS wiring is what keeps your setup safe and dependable. Take your time, follow a structured process, and prioritize safety over shortcuts. When a lithium system is wired properly, it becomes one of the most reliable and efficient parts of your off-grid setup. And if you want the full checklist and step-by-step guide, head over to Selfcampers.com. If this helped you avoid a costly mistake, subscribe for more practical off-grid and self-sufficiency guides.